Hello, welcome to the NeuroCave visualization tools usage demo. Today we're going to go through each of these controls on the screen and demonstrate what they do. So first thing you might notice is the dual viewports. This supports a range of analytical tasks like comparing different data sets, which you can select up here in the subject category line dropdown, and or the same data set with different coordinate system transformations in this dropdown. The views are linked, so clicking on a node on one view performs the same operation on the other view. This opacity slider allows you to control the opacity of the edges that are displayed when a node is clicked. The left mouse button rotates the scene. The right mouse button, when you click and drag, moves the scene around. The mouse wheel zooms in and out of the center of the viewport of the view. And the sync button syncs the camera angle and position to the other viewport. So if you move it off the screen and can't find it, you can click sync and get back to where the other one is. So we're looking at the 30,000 millisecond timestamp of the calcium variation simulation for the SciViz challenge. We can click that drop down and select maybe the 50,000 millisecond timestamp. Doesn't look much different. There's not much evolution of edges here, but if we take a look at the UMAP transform in the coordinate system, on a larger scale, the nodes are starting to have this linear configuration, starting to form sort of a line attractor that is indicative of n-gram formation. Now, NeuroCave includes a range of display customization controls. There's an interactive legend that shows the color codes used in the model, but clicking on one of these will make that particular color it'll make it translucent. It'll make that group translucent if you click it once, or if you click it again, it'll make it disappear entirely. And there's also this toggle button up here that toggles the state of all of the color groups. And clicking it once, as you can see, makes every color group that was previously fully visible, makes it dim, and the one that was dim is now fully visible. Clicking it again makes every group that was visible disappear, and the group that was fully visible now appears dim, which you can see it's this one here. So this clearly identifies this group, and if we're interested in it, we can click on some nodes in it and see their edges show up without having the clutter of all the other groups. You can see it in both viewports, so you can have the anatomical as well as the UMAP transformations. You can compare the effects of whatever you do in both of those. And if you click toggle again, it makes everything appear and makes this selected one disappear. Now you can make it reappear with your node selection changes. So I've shown you the edge opacity control here. There's also the edge threshold control. So sliding the threshold slider raises the bar for which edges get displayed based on their weights. So if it's too high, if it for an edge, then it won't appear. So that these edges are all below 1.87, but they're above 0.957, so they're visible at this setting, but invisible at that setting. This is useful for eliminating the clutter of low weight edges. This button toggles the Skybox. These sliders down here adjust the node sizes. By default, the left and right size slider controls are linked, but you can click these locks to unlink them, so now they're independently controllable. Now the color coding selector, it's currently set on anatomy. It'll allow you to set it to other color coding schemes. So the UMAP color coding scheme, for instance, codes the colors based on their patchwork clustering in the UMAP representation. So now you can see how a patchwork in the UMAP transform space maps to the anatomical space, and get a better feel of how the anatomical positions of the nodes influence their topological connectivities on a broad scale. Also, there's a number of heat map values calculated from the average of the various simulation parameters over the timestamp range. So here's the calcium heat map. We select the calcium heat map on both sides and see if there are any hot spots. And finally, there's the show line plots. This is a new feature. This button enables the evidence line plots. These are the raw data that determines the edge connectivity weights. In this case, it's the firing spike trains for all the nodes that you clicked on. So say we want to click on this outlier node, and when we hover over it, its ID appears in the info panel down here. So it's 21893, and if we click on it, the edges appear, and also its spike train is added to this column of spike trains. That helps you identify which spike train goes with which node you're looking at. Well, and now these buttons down here, they're inactive right now. VR does not support it because I don't have a VR headset plugged in right now. But in the next video, I'll plug in a VR headset, and these the text will change to enter VR. The buttons will light up, and you'll be able to click on this to enter this scene in your VR headsets, or this scene if you select it on this side. And we'll explore that in the next video. Thanks for joining this NeuroCave usage demo. Give it a try with the link below.